Alright, so in this course, I'm going to be using JSBin to show you how to implement these JavaScript algorithms. Another alternative is CodePen, and so I already have an account, so I'm going to log in. And so select all squares with bridges, refresh, traffic lights. Okay. I have an account. I'm trying to log in. I'm already logged in. So yeah, so I'm already logged in. And so what you would do is you would click on the create button here, and we're not going to be using any HTML, so we can minimize this. Minimize. We're not going to be using CSS either. So we're just going to be using JavaScript editor and the console. Alright, and with JSBin, I'm going to be using JSBin because it's just more straightforward. Plus, you don't have to sign up with JSBin. Like, you can still use it as a guest, but if you want to, you can sign up, have a JSBin account. But I don't. So, and again, just click JavaScript in the console, and we're going to be using that. So, also in this course, don't be afraid to ask questions. There's no such thing as a stupid question. Um, if you see someone ask a question, don't be afraid to answer it. That would be a big help for me. Some extra info to know is learning JavaScript is very easy to learn. Uh, I would say easier than learning Python, and learning Python is pretty easy, but once you learn how to do algorithms in JavaScript, it becomes a lot easier to do algorithms in other languages like Python, Java, and PHP, for example, along with Ruby. So whenever you sign up for another programming language course that teaches algorithms in that language, you're gonna learn things a lot quicker. So this here is a great start. I also want to add that in this course, my goal is to help you be more confident as a JavaScript programmer and be a lot more competent and confident in your abilities to excel in coding interviews, in particular whenever applying for JavaScript developer jobs or any type of programming job. There's always going to be a coding interview, and it's guaranteed that you will be questioned and tested on algorithms. All right. So after you take this course, you should have a much more clear way of seeing and thinking about algorithms and coming up with your own algorithms of your own. And there's an infinite number of algorithms that you can make. This course is to get you into the mindset of thinking in a algorithmic way and realizing your potential as a JavaScript programmer, or whether it be you taking this course and you later on deciding to get into PHP or Python or Java or or Ruby, for example. All right. You will be a lot more confident when learning about other programming languages. So, this is a really big step for you, and I'm very happy to teach you this content. And hopefully, and I am confident that this course will definitely help you and make you a much more fearless programmer. In this video, I will show you how to find the longest word in a string using basic JavaScript algorithmic scripting. So in other words, we will go through each word in each string and figure out which word in each string is the longest and return not the word but how many characters it has. So we're going to start with, you clear this, I'm going to start with the keyword function, and then our function is going to be called find longest word, and then with variable string open close parentheses, I'm going to have a variable called words, and we're going to set words equal to string dot keyword function split. Okay, each word has space around it, so we're going to split the string based upon the empty spaces so we can count each variable, each character in each word. I have another variable called max length, so we can find the max length of the longest word. We're going to initialize it to 0, and we're going to have a for loop with variable I initialized to 0, and I is going to be less than the length of a word, and it's going to be incremented by 1. And count each character one by one, and then if the length of a word is less than, if a length of a word is actually greater than the max length, or in other words, if it's greater than 0, or if it is not a empty space, with close parentheses, then we're going to set max length set equal to words dot length, and then right underneath the for loop, we're going to return max length so we can get the max length of the longest word. And then we're going to console.log, and then copy this, copy this string. Actually, first I'm going to copy this twice. Alright, I'm going to copy this string, paste it in here. I'm going to copy this string here, paste it in here, and then going to run it. And for the first console log, we get 6, because in this line, jumped is the longest word because it has 6 characters, and the other words either have 3, 4, or 5. And in this string here, this word is the longest, obviously. It has 19 characters. And these other words in the string has nowhere near as many characters as this long, big word here. So which is why we get 19 here. This is just a basic solution, but I'm going to show you other ways how you can make a script that can return you the same result. Alright, so we've done the basic solution for this script. Now I'm going to show you the intermediate level JavaScript developers solution for this. So this would be the intermediate solution. Alright, and for find longest words, I want you to delete all of this, and instead I want you to type keyword return. So type return, and then I want you to change this string here, or you can keep it to string, or if you want you can just make it S. But I'm gonna continue to use string. So return string dot split function keyword, and then single quote space open close parentheses dot to instantiate the reduce keyword function, and then we're gonna use the word function, and then x y, make sure this is the space, and then open close parentheses here, make sure you leave a semicolon there, and then in between here we're going to type return keyword, and then we're going to have the math function instantiate max, and then x y dot length, and then here have a comma, and then type 0, and then if you hit the clear button and then run it again, we get the same result. Alright, and this would be it for the intermediate solution, and in the next lecture I'm going to show you the advanced solution. So now I've shown you the intermediate solution, now I'm going to show you the advanced solution. Alright, and then we're going to delete this. So we're going to have string set equal to string dot split empty space, turn string string splice 1, return find longest word dot join, and I'm going to copy this. Alright, instead of this, going to have less than or equal to, and I'm not gonna have splice. There'll be no splicing here, and instead I'm going to have str slice, and then have str, and we will have one str length, and then dot join. Okay, we have that, and then at last we will have return string length, right? And then hit the run button, and we get the same result, 619 for the advanced solution. So this advanced solution also works as well. See you in the next lecture, and I'll show you how to reverse a string, reverse a string basic script. Alright, in this lecture, I'm going to show you the first solution on how to reverse a string, and there's 4 different ways in which I'm going to show you how to do this. So to further explain this to you, we need to take the string and reverse it. So if it originally reads hello, it will now read OLLEH. We will need to split the string, and therefore we will be working with arrays as well. So first way, so we're going to be using the strings hello, howdy, and greetings from Earth. And as you can see here, you can stop and pause the video and copy this here, these 3 lines. I've already inserted our function with our input inside of the function within the console logs. So now I'm just going to fill in the local end block here within this function. So I'm going to do str equal to str dot split, and then str equal to str dot reverse, alright, and then str equal to str dot join, double single quotes again, then return str. Alright, now I'm going to click run, and here you can see HOL, you can see hello backwards, howdy backwards, and greetings from Earth backwards. And in the next lecture, I'll show you the second solution. Now for the second solution for reversing a string, I want you to create a variable called new string, set that equal to empty quote, and then a for loop, var I initialized to string dot length -1. So initialize to the length of the string -1, and then I is going to be greater than or equal to 0, greater than or equal to 0, and then I will be decremented by 1, and then we will have new string added to str plus equal to sign stri, and then we will return new str, new string. Alright, I'm going to clear my console and then I'm going to run it again. And here we get the same result: hello backwards, howdy backwards, and greetings from Earth backwards. See you in the next lecture for the third solution. Now for our third solution, it's going to be slightly different from the second solution. So to show you, I am going to create a variable called rev for reverse. Set that equal to an empty string. And then I'm going to have string dot split, open close parentheses, empty string as a parameter, as an input, for, after for loop again, var I equal to string length minus 1, and then I is going to be again greater than or equal to 0 decremented by 1, and then reverse plus equal str I, and then we're going to return reverse and click the run button, and again we get hello backwards, howdy backwards, greetings from Earth backwards. And in the next lecture I will show you a much more simpler way with the fourth solution. See you in the next video. Alright, so for the fourth solution, it's going to be a lot more simple than the past three. So I want you to write the return keyword, then string, split, open close parentheses, single quotes, empty single quotes, then dot reverse to instantiate the reverse method, open close parentheses, dot join, single quotes, empty single quotes, then semicolon, and then I'm gonna click run, and we get the same thing again for the fourth time: hello backwards, howdy backwards, greetings from Earth backwards. And as you can see, this only requires one line of code instead of 3 or 4 lines of code. A lot more simple. Alright, see you in the next lecture video. Alright, so with this algorithmic script, there will be 3 different solutions I'm going to show you. But for this first one, I'm going to first explain that we're going to return the factorial of a provided integer if the integer is represented with a num or a number. A factorial is the product of all positive integers less than or equal to that number. Factorials are often represented with shorthand notation. So for example, the shorthand notation will be the exclamation mark. So this is how the notation is done. Alright, so I'm going to create a function. So we're going to use the keyword function and then factorialize, and then num, the number that will be factorialized. And then we're going to create a variable called result, and we're going to initialize it to 1. And then we're going to create a for loop, and we're going to create a variable I, local variable I, and initialize it to num, and then semicolon, and then I will always be greater than 0, and we will decrement I by 1 for each loop. And then inside the for block, we're going to do result asterisk equal to, or multiply equal to I, and we're going to return result, return keyword result, and then we're going to console.log, and we're going to factorialize, and then the first integer is 5. So I'm going to copy this 3 more times. And I'm going to change this to 10. I'm going to change this to 20. I'm going to change this last 5 to 0. Alright, and then we click run. And these are the factorial results that you should get: 120. And then we have 3,628,800, and then we have this really big huge number right here, and then we just have 1 because the factorial of 0 is always equal to 1, which is a general factorial rule. And I will see you in the next lecture for the second solution. Alright, so for this second solution, we're going to do something a little bit different. We're going to do if operator equal to equivalent to 0, return 1, return num, times factorialize num minus 1. Just save space, make it closer like that. Minus 1. And now I'm going to click run. And as you can see, we get the same numbers: 120, 3,628,800, and this really big huge number right here, and we get 1 again. Alright, and I'm going to show you a third solution, which will be the last solution. Alright, so for this last solution, within our factorialize function, we're going to use a for loop, and then var a initialize to 1, and then num is greater than or equal to 1, semicolon, and then num will be decremented by 1. And then we're going to do a times equal to num, and then return a. Alright, and then we're going to click run, and we get the same result. So this is another correct way of doing this. And in the next lecture, I will show you the algorithm for how to check for palindromes. See you in the next lecture. Alright, so in this video, we're going to create a algorithm that checks for palindromes. Our goal for solving this problem is tidying up the string passed in and checking whether it is in fact a palindrome. If you are unsure of what a palindrome is, it is a word or phrase that when reversed spells the same thing forwards or backwards. A simple example is mom. When you reverse the letters, it spells the same thing. Another example of a palindrome is race car. When we take out anything that is not a character, it becomes race car, which is spelled the same forwards or backwards. Once we have determined whether it is a palindrome or not, we want to return either true or false based on our findings. So go ahead and copy what I've done so far. And once you get done pausing and copying, follow after me. Within our function, a local scope of our function, we're going to assign a front and back pointer. Then we're going to let front be initialized to 0. And then we're going to let back be initialized to string length minus 1. And then back and front pointers won't always meet in the middle. So use back is greater than front. So while back is greater than front, increment front pointer if current character doesn't meet criteria. So while string front dot match open close parentheses slash backslash and open close brackets and then backslash and then capital W and then underscore and then forward slash after the closing bracket, and then front incremented by 1, and then continue, and then decrement back pointer if current character doesn't meet criteria. Alright, so while string back dot match, do the same thing, backslash the close brackets forward slash capital W underscore and then so back decremented by 1, continue, alright, and then we're going to finally do the comparison on the current character. So if string front to lowercase not equivalent to the back string dot to lowercase. Then we're going to return false. Otherwise, front incremented by 1, back decremented by 1. Alright, and after that, if the whole string has been compared without returning false, it's a palindrome. And then we will do return true. Alright. And then I'm going to click run. And it says true. It is a palindrome. Because when you spell I backwards, you still get EYE. It's EYE forward and backwards. So you should get true. And this will be it for palindrome algorithm. And in the next lecture, I will teach you how to make an algorithm to title case a sentence. See you in the next video. Alright, so we're going to title case a sentence with this basic code algorithm. So first, I'm going to create a string constructor prototype. So it's going to be called replace at. And set that equal to function index comma character, and then with the return keyword this substring 0 comma index plus character plus this dot substring index plus character plus dot length. Alright, comma, then put another comma here, and then within our function I'm going to create a variable called new title. Set that equal to string dot split with a space in between the single quotes, and then var updated title equal to an empty array. I'm going to have a for loop, and we're going to have a variable called st for string in new title, or sentence in new title. And then within our for loop we're going to have updated title and then open close brackets st sentence new title open close brackets st dot to lowercase dot replace at zero new title character at 0 and then after the for loop, type the return keyword, and then updated title dot join space in between the single quotes, and then we're going to click run. And then as you can see, all of the first letters of each word is capitalized. Now with our input, only the I here is capitalized because it's a general rule for beginning a sentence. I'm a little teapot. So basically, we've returned a sentence with a title case. This means that the first letter will always be in uppercase and the rest in lowercase. And as you see that here. Alright, and then I'm going to show you the intermediate way to do this. Alright, so for our intermediate solution, within our title case function, create a new variable called convert to array equal to string dot to lower case open close parentheses dot split, and then I'm going to create a new variable called result, set that equal to convert to array dot map function value, and then in between here we're gonna the keyword return val dot replace val dot char at 0 val dot char at 0 again, and then dot to uppercase open close parentheses, and then we're going to do the semicolon here as well, and then underneath we're going to do return result dot join semicolon, and now I'm going to click run again, and as you can see we get the same result. So this is another solution here, a little more advanced, and in the next I'm going to show you a much more advanced solution than this. See you in the next lecture. Alright, so for the advanced solution, within our function here, I want you to type the return keyword string dot to lowercase dot replace open close parentheses / open close parentheses the up, this is the power key, and then backslash, and then S, and then backslash again, capital S / G, comma, L root, L dot to uppercase open close parentheses semicolon. Okay, and this is like regex right here. Yeah. All right, now I'm going to click run, and as you can see, we get the same result. Our sentence "I'm a little teapot" is title case, first letters uppercase, the rest of the letters lowercase. And I'm going to show you a second advanced solution in our next video. And then we will go on to return largest numbers in arrays after the next video. Alright, so now within this advanced solution, I want you to type string equal to string dot split, open space within single quotes, and then a for loop which will have var equals to var I initialized to 0, and then I is less than the length of the string. And then I'm gonna increment by 1, then string I equal to string I dot lowercase dot split, and then string I 0 to string I 0 dot to uppercase, and then string I equal to string I dot join semicolon, and then return str join. Alright, and then I'm gonna click run, and that's not supposed to happen. Believe, see if I close this. There we go, hold on. There we go. Yeah, I had to, this is just supposed to be an empty string, not an empty string with a space in there, except for right here and here. Okay, so yeah, we split, and then in this title case string, we have the title case sentence, all capital letters for the first letter in the word, and the rest lowercase. And now we'll be going on to return the largest numbers in a array. Alright, in this lecture, I'm going to show you the basic code solution for returning the largest numbers in a array. So here, we will get an array that contains subarrays of numbers, and you need to return an array with the largest number from each of the subarrays. So within this array, num array, we have 4 subarrays, and each of the 4 subarrays have 4 numbers, and from each of these subarrays we're going to create an algorithm that can select the highest number from each array and then create a new array with the highest numbers from each of these 4 arrays. So you're going to create a function called largest of 4, and then we're going to have a parameter of array, and then within our function we're going to create a variable called var results equivalent to an empty array, and then we're going to have a for loop var n initialized to 0, and then n will be less than the length of the array, and n will be incremented by 1. And then we're going to create a variable called largest number, which will be equal to array in 0. Alright, so we're going to create that within our for loop. And then within this for loop, we're going to create another for loop. And then we're going to have var sb equal to equivalent to 1. And then sb is going to be less than array in dot length. Okay. And then open close parentheses. Oh, and then SB is going to be incremented by 1. And then within this, inside this array, we're going to have a if statement. Alright, and then array in the coordinates in SB is greater than largest number in close parentheses, then the largest number is equal to array sub n. Okay, so right here underneath the second for loop, we're going to have results n equal to largest number and then after the first initial for loop, the first one, I'm going to type return results. And then I'm going to click run. And then in this array we have 999, 798, 1023, 555, because these are the highest numbers within each array. Okay, and as you can see within the first subarray, 999 is the highest number. Within the second subarray, 798 is also the highest number within this subarray. 1023 is the highest number in this third subarray, and 555 is the highest number in this last subarray. So to further explain this code, we create a variable to store the results as an array, create an outer loop to iterate through the outer array, create a second variable to hold the largest number and initialize it with the first number. This must be outside an inner loop, so it won't be reassigned until we find a larger number. Create said inner loop to work with the subarrays. Check if the element of the subarray is larger than the currently stored largest number. If so, then update the number in the variable. After the inner loop, save the largest number in the corresponding position inside of the result array, and finally return said array. Alright, and now I'm going to show you the intermediate way to do this. Okay, so within um, our intermediate approach, within our function, hold on, within our function largest of 4, we're going to type the return keyword and then array, then map, and then we're going to have function and then group, and then we're going to use the return keyword again, group dot reduce function previous current, and then here we will have use the return keyword again, and then current greater than previous, or if current is not greater than previous, then okay, and then we're going to so semicolons here and here. Alright, so here what we just did, we map all items within the main array to a new array using the array prototype map function and return this array as the final result. Within each inner array, we reduce its contents down to a single value using the reduce here. The callback function passed to the reduce method takes the previous value and the current value and compares the two values here. If the current value is higher than the previous value, we set it as the new previous value for comparison with the next item within the array, or returns it to the map method callback, or returns it to the map method callback if it's the last item. So as we click run, we get the same result. We get 99. That's the highest number for the first subarray, 798 for the second subarray, 1023 for the third subarray, and 555 for the last subarray. And next I'll show you the advanced code solution. Alright, so for the advanced code solution, within our largest of 4 function, I'm going to use the return keyword again, and then array map, and then function dot apply dot bind, and then math max null. I believe this is supposed to be a capital F. Alright, and a semicolon here, and now I'm going to click run again, and we get the same output: 99, 798, 1023, 555, because those are the highest numbers within each of the 4 subarrays within the num array. So for further explanation of what we just did, we build a special callback function using the function bind method that works just like math.max, but also has the function prototype applies ability to take arrays as its arguments. We start by mapping through the elements inside the main array, meaning each one of the inner arrays. Now the need for a callback function to find the max of each inner array provided by the map. So we want to create a function that does the work of math.max and accepts input as an array, which by it doesn't by default. In other words, it would be really nice and simple if this worked by itself. So for example, it would be really nice if this worked by itself. Math.max, and then you have 9, then you have 43, then you have 20, then you have 6, right? And then this would result in 43, but it doesn't work. To do the work of accepting arguments in the shape of an array, there is this function, i.e. math.max.apply null. So we would do math.max.apply, and then null, which would invoke something like a max method. What we're looking for, almost. Here we're passing null as the context of the function prototype apply method, as math.max doesn't need any context since array map here expects a callback function, not just an expression. We create a function out of the previous expression by using the function dot bind method. Since function prototype apply is a static method of the same function object, we can call the function prototype bind on function prototype apply, i.e. the function apply bind method. Now we pass the context for the function prototype apply bind call. In this case, we want math.max here. So we gain its functionality. Since the embedded function prototype apply method will also require a context as its first argument, we need to pass it a bogus context. So we pass null as the second param to function prototype apply bind, which gives a context to the math.max method. Since math.max is independent of any context, hence it ignores the bogus context given by the function prototype apply method call. Thus, our function prototype apply dot bind math.max null makes a new function accepting the array.map values, i.e. the inner arrays. And this would be it for returning the largest numbers in subarrays. And in the next video, I will show you how to do a confirm the ending algorithm. Alright, so in this first part solution, in confirming the ending algorithm, our function confirm ending is a whole Boolean operation. We need to return true if the first argument ends with the second argument. This means that for the problem script, it should return true for the confirm ending function input bastion, bastion as our string, and then the target n, because n is at the ending of bastion, and it should return true in our console. So within our function, going to use the return keyword, and then string, and then substring, and then negative target. Let's start. I guess this flips it backwards. And then negative target dot length. And then equivalent to target. Alright, so to further explain what I just did, the substring method returns the characters in a string beginning at the specified location through the optional specified number of characters. Substring operates through the end of the string if the second optional parameter is not specified. Substring calculates the index of the first matching character from the string's end if the specified location is negative. Using the negative operator in front of target dot length makes it negative. We use the method substring with the negative value of target's length to extract the ending segment of bastion. I'm sorry, to extract the ending segment of string of the same size as target. Compare it to target and then return the value of this Boolean expression. So now, as I click run, it returns true here. Alright, and so this is the first solution, and in the second part solution, I'm going to show you a different way on how to do this. Alright, now for the second part solution for this algorithm, within our function, I'm going to create a if statement, string dot substring string dot length minus target dot length string dot string dot length, then not equal to target, then return false, else return true. And then after the if statement, I'm going to use return string and now we're going to change this up. Instead of bastion, we're going to he has to give me a new name, and then our target is name. So we're going to, instead of doing this for a character, we're going to do this for a word to see if there is if name is at the end of this sentence. All right, and so now I'm going to click run, and it's true because name is at the end of this sentence, obviously. All right, and this will be it for the confirm ending algorithm. And the next basic algorithm I'm going to show you is repeat a string, repeat a string. All right, so this program is going to be very simple. We have to take a variable and return that variable being repeated a certain amount of times. No need to add space or anything. We're just going to keep repeating it into one single string. So we're going to repeat a given string, the first argument here, string, num times the second argument, and return an empty string if num is not a positive number. So I'm going to make a if statement. It's going to be num if num is greater than 0, then return string repeat num, and if num is not greater than 0, then return an empty string. And now I'm going to click the run button, and as you can see, we get an empty string for the first console log because that -1 is less than 0. So we're going to get an empty string here. And then for the second console log, we have a +4, and string repeats 4 times. So we would get candy, apple repeated 4 times in this string right here. So to further explain, we create an empty string variable to store the repeated word here with string. And then also you can as well use a while loop or a for loop to repeat code as many times as needed according to num as well. But instead we use the if statement. Then we just have to add the string to the variable created on step 1 and increase or decrease num depending on how you set the loop. At the end of the loop, return the variable for the repeated word. Alright, and on to the next lecture. Alright, so the intermediate developer way of making this algorithm is we would do an if statement again, and then num is less than 0, and then, or actually what you can do is return empty string, and then if num is equivalent to 1, then we return string alright, and then else return string plus repeat string num times num minus 1. Alright, so I'm going to click run, and it gives us the same result, an empty string for the first console log because the number is negative, and then it returns candy apple 4 times because of the +4 digit. Now this solution uses recursion. We check if num is negative and return an empty string if true. Then we check if it's equal to 1. And in that case, we return the string itself. If not, we add the string to a call of our function with num being decreased by 1, which will add another string and another until eventually num is 1 and return that whole process. Alright, so for our advanced code solution, we're just going to use the return keyword here, and then we're going to do num greater than 0, and then question mark, and then str dot repeat, open close parentheses, and then in between num. Hold on. And then after that, we're going to do semicolon, and then we're going to have empty string, and then semicolon, and then colon. Alright, so I'm going to click run, and we get the same result. We get the empty string for the first console log, and then candy apple 4 times for the second console log. Alright, and to explain this solution, it takes a declarative approach. It is similar to the second solution, except it uses the ternary operator form of the if statement. And that's it. Alright, so basically if num is greater than 0, if this is true, then repeat 4 times. But if num isn't greater than 0, then put out an empty string. So this puts out if num greater than 0 is false. Alright, see you in the next lecture. So, truncated string. We need to reduce the length of the string or truncate it if it is longer than the given maximum length specified and add to the end. If it is not that long, then we keep it as is. Truncate a string. Here, our first argument, if it is longer than the given maximum string length, which is the second argument num. Return the truncated string with a ending. So keep note that we will be inserting 3 dots to the end, and that will add to the string length. However, if the given maximum string length num is less than or equal to 3, then the addition of the 3 dots does not add to the string length in determining the truncated string. So we're going to start out with an if statement, and then we're going to have string dot length greater than num, and num greater than 3, close parentheses, return string dot slice 0 num minus 3, concatenate 3 dots. And then else if string dot length greater than num and num less than or equal to 3, then we will return string dot slice 0 comma num, concatenate 3 dots, and then we will return string. And then I'm going to click run, and we have orange as our string, and then we're going to use 1, 3, and 7 to test out each case of our logic statement here. So for the first, we have just O because 1 is less than 3. Alright, and we have ORA because 3 is equivalent to 3. So our num is equivalent to 3 for here. And so we get ORA. And then because you have the the 0 index, 1 index, 2 index. And then because this one is less than 3, right, we just get the 0 index. So 0, just the first index. Then we get the whole word orange in our string because 9 is greater than 3. And our string length is greater than 1, 2, 3, 4, 5, 6. So our string length here is less than our num. But yeah, so and now I'm going to show you the advanced solution to this algorithm. Alright, so for our advanced solution, I want you to copy this. I'm going to paste this in between our truncate strings function. So we have an if statement, and if the string length is greater than our input number here, then we will return the string that will be sliced, and with our context number 0 here for our first argument, so it will begin at 0 and then it will be sliced. So it will be sliced if the number is greater than 3. If this is true, then num will be subtracted by 3. And so for example, let's say if the number is 1, orange has 6 characters. The string length is 6. It's greater than 1. Now, our number 1 is not greater than 3. It's false. So it would just be 1. So beginning from 1 to index position 1, then it will be sliced. It will be sliced at position 1. So you would just be left with O dot dot dot. And then for 3, 6 is greater than 3. So it will go to this argument here. So starting from position 0, 3 is not greater than 3. It's equal to 3. So it will go here. So it will be sliced at position 3. So you will have ORA because O is 0 index position, R is 1 index position, A is the 2 index position. So you have ORA 1 dot dot dot, and I'm going to show you. I'm going to click run. And then for 7, 6 is not greater than 7. So it would just output the string orange. It would just output this whole string. So that's the reason why you see orange here. And then for 9, 6 is not greater than 9. So it would just output orange again. And then you have this here. Alright, and we use a ternary operator inside for our second argument, for our second context number. Alright, and now see, and that will be it for this video. And in the next lecture video, we will do the chunky monkey algorithm. Alright, so for our chunky monkey algorithm, we're going to write a function that splits an array with our first argument into groups the length of size second argument and returns them as a two-dimensional array. So for example, if this array here, we have this array and the number is 2, so we're going to have this in groups of 2. So in one subarray you have A, B, another C, D. For this one, to this array. I'm going to split this into groups of 3. So you're going to have 0, 1, 2, and then 3, 4, 5, and 2 different subarrays. And then same with this, groups of 2. And then same with this, groups of 4. You have 2 subarrays here. So now we're going to create the logic within our chunky array in groups function with the parameters array and size. Alright, and so now I'm going to create a variable var called temp, and this is going to be equal to a empty array. It's like a temporary empty array, and then another variable called result on a result array. And I'm going to have a for loop with var and then a initialized to 0, and then a is going to be less than the length of the array, and then a is going to be incremented by 1. And then for the temp array, we have temp dot push close parentheses array, and then a index, and then well, this is going to be inside of a if statement, so I'm going to cut this, and then if a modulus size is not equivalent to size minus 1. Then we're going to paste this, and then else temp.push array index a, and then result dot push temp, and then temp equivalent to a empty array, and then underneath our for loop I have a if statement, and then if temp dot length is not equivalent to 0, or we're just going to do it not equivalent to 0, and then result dot push temp, and then return result. And we're going to click run, and as you can see, we get the same result as we expected to the left here, except for 4 is missing. See if I input this right. Zero, 1, 3, 4. Expected to be 0. Oh, I left out 2. Yeah, be clear. Okay, now that looks about, yeah, that looks right now. Alright, and as you can see, we get the same result as we do on the left here. So this is our logic here. The chunky, and now I'm going to show you, well, first let me explain what we've done. Firstly, we've created 2 empty arrays called temp and result, which we will eventually return, and our for loop loops until a is equal to or more than the length of the array in our test. Inside our loop, we push to temp using temp.push array index a if the remainder of a divided by size is not equal to size minus 1. Otherwise, we push to temp. Push temp to the result variable and reset temp to an empty array. Next, if temp isn't an empty array, we push it to result. Finally, we return the value of result. Alright, and I'm going to show you that a way that's a little bit more advanced than this in our intermediate code solution. See you in the next video. Alright, so for the intermediate solution, I'm going to do something a little bit different, and we're going to create a variable called array2 equivalent to an empty array, and then we're going to have a for loop, and then var I initialized to 0, and then I is less than the length of the array, and then I incremented by plus equal I equals I plus size. So incremented by size, and then array dot push array two dot slice I for the first parameter, and then I plus size. Alright, and then want to return array 2. Alright, and now I'm going to click run. Hold on. Actually, this is supposed to be array. Change this from array 2 to just array. And I'm going to click run again. Okay, and as you see, this output matches this on the left. So to explain what we did, first we created an empty array, array2, where we will store our chunks. The for loop starts at 0, where I is initialized, increments by size each time through the loop here, and stops when it reaches array length, where I is less than array length. Note that this for loop does not loop through array. It does not loop through this. Instead, we are using the loop to generate numbers we can use as indices to slice the array in the right location. Inside our loop, we create each chunk using array.slice here. We use array.slice I, comma, I plus size, and add this value to array2 with array2.push here. Finally, we return the value of array2 so that we can get this output in our console. And now I will show you an even more advanced way to do this algorithm in the next lecture. Alright, so for our advanced algorithm, we're going to create a new variable called new array, initialized as a empty array. And then we're going to have var I equal to 0. So I will be initialized to 0. And then we're going to have a while loop. And then I is going to be less than the length of array, our parameter. And then new array will push array and then slice with I from I to I plus size, then comma, and then we're going to increment I by size each time it goes through the while loop, through each cycle of the while loop. And then we're going to return new array. All right, now I'm going to click run and we get the same output. And to further explain, firstly, we created two variables. New array is an empty array which we will push to. We also have the I variable here set to 0 or initialized to 0 for use in our while loop here. Our while loop loops until it is equal to or more than the length of the array in our program. Inside our loop, we push to the new array using array.push, and we do that by using the array.slice from the I index to the I plus size index. For the first time it loops, it will look something like, for example, I will be 0 and then 0 plus 2. After we push to new array, we add the variable of size unto I. Finally, we return the new array here. And that's how we get this. And I'm going to show you another advanced way to do this in the next video. Alright, so another advanced way to set up this algorithm is by creating a new variable. We're gonna call it new array. I'm gonna initialize it to a empty array. And then we're gonna have a while loop. And then array length. And then new array. So basically, if it's true that there's an array length, which means if it's true that there's an array, basically, then push array dot splice from index 0 to index size to the size, and then comma, and then after the while array we're gonna use return new array. So we're gonna return the new array, and then we're gonna click run, and we get the same output. And so firstly, we created a variable. New array is an empty array, as you can see here, like how we did in the previous video. And new array is an empty array which we will push to here within our while loop. Our while loop loops until the length of the array in our test is not 0. Inside our loop, we push to the new array using array.splice 0 comma size. For each iteration of while loop, it deletes size number of elements from the front of array and push them as an array to new array. Finally, we return the value of new array. So it's spliced from index 0 to the length of the array, the size of the array. Alright, and yeah. So in the next video, I will show you the slasher flick algorithm. Alright, so this algorithm would be called the slasher flick. We return the remaining elements of an array after chopping off n elements from the head. The head means the beginning of the array or the 0th index. So to give you an example, let's say with our function slasher, our array is 1, 2, 3, and then we want to chop off the first two indices, first two items, right? That means the array must return 3 because 3 will be the last item within the array that doesn't get chopped off. So first we're going to remove the head. We're going to create a function called slasher with parameter array and then another parameter for how many items within the array that's going to be chopped off. So the first part we're going to remove the head, and then second part we return the remaining or the tail. So within our slasher, let's say we have 1, 2, 3. We're going to use this for an example, and what we're going to do is we're going to do array dot splice from the 0th index to how many we're going to cut off from the head of the array, and then return array. And then if I click run, we get 3 as expected over here. And let's say I copy this, and let's say we change this up to 4, 5, 6, 7, and let's say we're going to chop off 4, then we run it again, and then we chop off the first 4 items from the array, and then we should be left with 5, 6, 7, and we're left with 5, 6, 7 within the array, within our console log. Alright, and this will be it, and then I will show you another much better way to do this in the next video. Alright, so a much better way to do the slasher flick algorithm, a more advanced way, would be to just simply use the return keyword and then array.slice and then how many, and then semicolon. Next I'm going to click run, and as you see, like in the previous video, the remaining we get just 3 in this array and then 5, 6, 7 in this array. So this is a much simpler way of doing this. Alright, and on to the next algorithm, which will be mutations. Alright, so I'm going to show you the first basic solution for the mutations algorithm, and in this algorithm we're going to return true if the string in the first element of the array contains all of the letters of the string in the second element of the array. So for example, with hello and hello, this should return true because all of the letters in the second string, all of the letters in the second string are present in the first string. And the same with this argument. This should return false, hello and hey, because the letters within the second string are not within this first string. And this should return true because the letters in this string is also within the first string. Alright, and for hello and hey, it should return false because the string hello does not contain a Y. Lastly, with alien and line should return true again because all the letters L, I, N, E are present in alien. Alright, and so return true if the string in the first element of the array contains all the letters of the string in the second element of the array. So we're going to create a variable called test equal to array at index 1 to lowercase and then var target equal to array at the 0th index, and then turn that letter character into lowercase. And then we're going to have a for loop and have var I initialize to 0, and then I should always be less than test, the length of test, and increment it by 1. And then within this for loop, we're going to have an if statement of if the index of target.index of test, open close brackets, and then I in the middle is equivalent to -1, then return false. And then underneath the for loop, we're going to have the return keyword and then true. And now I'm going to click run. Oops, hold on. And I am messing up because var target, maybe I misspelled something. Oh, that's right. I made a typo here. It's supposed to be uppercase. Alright, so now I click run. And now for the first console log, we have true. We have true for hello and hello. We have false for hello and hey. And then we have true for alien and line. Now, so to explain what I've done, first we make two strings in the array lowercase, which we did with the variable test and variable target. So we make the first two strings in the array lowercase. Test will hold what we're looking for in target. And then we loop through our test characters, and if any of them is not found, we return false. If they are all found, the loop will finish without returning anything, and we get to return true. And I'm going to show you a different way of doing this algorithm in the next video. Alright, so for our intermediate solution, we're going to use the return keyword, and then array index 1 to lowercase and then dot split dot every function letter and then within here we're going to have return array dot 0 to lower case. I'm going to have index of letter isn't equivalent to -1. All right. So now I'm going to click run and we get the same output, true, false, true. So to further explain, we grab the second string, lowercase it, and turn it into an array. All right, here. Then we make sure every one of its letters is a part of the lowercase first string here. Every right here will basically give you letter by letter to compare, which we do by using index of on the first string. Index of will give you -1 if the current letter is missing. We check that not to be the case, for if this happens even once, every will be false. Alright, and this will be it for this lecture. Alright, so this algorithm is called falsy bouncer. So we are going to remove all falsy values from an array. So remove all falsy values from this array here, falsy array. Now, falsy values in JavaScript are for example false, null, zero, empty string, undefined, and not available now. I don't have false in here. 10, 8, 9, 10, 11, 13, and then false. So what I'll do is I'll cut that, insert that in there. So we've got 0 in here. We've got null in the 4th place. We've got an empty string in the 6th place. We've got undefined in the 9th place here. We've got NaN, not available now, in the 11th place. And we've got false in the 14th place. Now, within our function bouncer with the parameter array, because this is where we're going to input our falsy array, And you can see I've already got it logged in here within the console log. Within this function, I want you to write return and then array dot filter and then open close parentheses boolean semicolon. Now I'm going to click run, and as you can see within this array, you do not see the 0, you don't see the null, you don't see any empty string in here, you don't see the undefined, the NaN, or the false. So we have successfully filtered out all falsy values within this function. See you in the next video. Okay, so this algorithm is the seek and destroy algorithm. And here we have our initial array with the given array values. And this will be the first argument in our destroyer function, which will be plugged in for the array parameter. And then followed by one or more arguments. And here we have our array1 argument, which we will plug in our new array values in here for this parameter. And we're going to remove all elements from the initial array that is also within this new array element. So I'm going within our destroyer function, I'm going to create a variable called args, and I'm going to set that equal to array.slice.call array1, and then I'm going to have a for loop with var I initialized to 0 with I less than the length of the array, and I will be incremented by 1. And then inside this for loop, I'm going to have another for loop with var j initialized to 0, and j is going to be less than args, the length of args, and then j is going to be incremented by 1. And then within the second for loop, I'm going to have a if statement, and it's going to be array initial array I of I index. If this is equal to args of jth index, then delete array of ith index. And then after our for loops, I'm going to use the keyword return and then array filter the array for falsy values or false boolean values. Okay. So array.filter, open close parentheses, boolean. Now I'm going to click run. And within this array, you see 23, 83, 95, 36, 81, and 91. And you see this because this is the new initial array, because the new array shares the same values within this initial array of 11. We have 11 in both these arrays. We have 41 in both of these arrays. We have 77 inside of both of these arrays. That's the reason why you don't see number 11, 41, and 77 within this new initial array. And to further explain this code a little bit more, we've created within our function, we've created an array of arguments using array.slice.call open close parentheses array1, and we stored it within this args variable, and we're going to use this to check against the initial array. Alright, and then we start a basic for loop to iterate through the array here, and nest another for loop inside of this first for loop, changing the integer variable j and array to args. And this second loop will iterate through args. Within the second loop, we create an if statement here, checking strictly if it's equal to that the current value of array array I is equal to args j. If the value at the current index is equal in both arrays, we use delete to remove it from array here. Outside of the nested loops, we return the modified array using the Boolean object here as a filter for any nulls created by the delete operator. And now I'm going to show you an even better way of doing this algorithm in the next lecture. See you there. Okay, so for the intermediate method of implementing the seek and destroy algorithm, it can be a lot more simple by just simply, again, creating a variable called args and then set it equal to array dot slice dot call open close parentheses array1 semicolon, and then return, close this, return array dot filter open close parentheses, and then function keyword, and then value as a parameter, and then we're going to use the return keyword again within this array filter function, and then return not args dot includes close parentheses value. Okay, and now I'm going to click run. As you can see, we get the same output as before in the last video. Okay, again, this still successfully deletes 11, 41, and 77 from the initial array because new array shares those same values within its array. Alright, and this will be it, and also a little explanation on what I did. So I declared a variable named args. Alright, set it equal to a new array object slice dot call the arguments with the array1 argument passed into the function. Okay, and this is used for, this line right here is used for separating the arguments and used for filtering into its own array. Alright, also this return filtered array using right here, this returning the filtered array using includes in the rollback function to check if value is not in args, returning true to keep the value in the original array or false to remove it. Alright, so see you in the next video. So here we're going to show you the where do I belong algorithm. So with that where do I belong algorithm, and by the way, this will be the first basic solution, part 1. Okay, and with the where do I belong algorithm, we're going to return the lowest index at which a value second, which would be the second argument, should be inserted into an array, which will be the first argument once it has been sorted. The return value should be a number. For example, with get index to ends for this array here, and we insert 1.5, this function should return 1 because it's greater than 1, which is the first index here, and less than 2 here. Alright, and for example, with this function, with this input here, we insert 19. It should return 2 because once array is sorted, it will look like 3, 5, 20. Alright, and with this same function, 19 is less than 20, the second index, index 2, and greater than 5, index 1. So this can be a tricky problem to understand. You need to find where in the array a number should be inserted by order and return the index where it should go. So within our getIndex2 insert function, I'm going to do array.sort and then function with parameters a, b, and then return a minus b, semicolon there, and then underneath this function create a for loop, variable a initialize to 0, and a is less than the length of the array, and a will be incremented by 1. And then within this for loop, we're going to have an if statement with array of index a if it's greater than or equal to the number that we insert, then return a. And then after our right underneath our for loop, right, return array length. Now I'm going to click run. For the first function we get 1, for the second function we get 2, for the third we get 1, and second we get 2. Alright, so basically 1.5 belongs in the 1 in the first index. Alright, 19 brings back 2, 50 brings back 1, basically in the 1 index. Alright, 19 in the second index, 500 in the second index. Alright, cause 0, 1, 2. Alright, 0, 1. Alright, 19. Second index. Alright, 0, 1, 2. So it would replace here. It will replace this number as the second highest. Alright. And this one it would replace at the 1 index here. Alright, so to further explain, first I sort the array using the sort callback function here with array.sort, and then to sort it by lowest to highest, I sorted it from lowest to highest from left to right. Then I use a loop. I use a for loop here to compare the items in the array starting from the smallest one. When an item on the array is greater than the number we are comparing against, then we return the index as an integer. Alright, and next I'm going to show you the second way you could implement this algorithm. Alright, so for the second part, within our function, again, we're going to use the sort method again with function, and then parameters AB, and then we're going to do return A minus B, and then we're going to create a variable I, initialize it to 0, and then we're going to use a while loop with num. If num is greater than array at the I index, then increment I. Once it's not, return I. Okay, and this should return 1 again, 2 again, 1 again, 2 again, because 1.5 should be inserted at this 1 index because it's not greater than 2. Alright, 19 after this array is sorted, which is really 3, 5, 20, will be inserted at the 2 index because it's not greater than 20, because then 20 will be at the 3 index, because instead of having 3 items, we'll have 4 items, and in an array it's 0 to 3 for 4 items within the index. And for 50, it will be at the 1 index because it's greater than 40 but not greater than 60, so it would be in between these numbers. And then for 500, it will be in the 2 index because 40 would be at the 0 index, 60 would be at the 1 index, 500 would be at the 2 index. Alright, and we run it again, and bam, we get the result that we're supposed to get. And so this way of doing it is also effective as well. And now, so I basically sort the existing array here, and then iterate through the array while checking if num is bigger. The loop will stop when num isn't bigger. When num isn't bigger than I, that's when the while loop stops and returns the last element checked. Alright, and now I'm going to show you the intermediate way of doing this. Alright, so the intermediate way has 2 parts. So I'm going to show you the first way, the first intermediate way. So we're going to use array.push, open close parentheses, num. I'm going to push the num, and then in our array we're going to sort our array. So after pushing the new number to our array, we're going to sort it. Function parameters AB, and then return A minus B, semicolon, and then return keyword again, and then array dot index of num. So it's going to output the index number of the number that you inserted after you've sorted. So insert the number within the array, sort all of the numbers within the array, and then return the index number of the number that you inserted after it was sorted. Okay, so now I'm going to click run, and we'll get the same output. Returns 1, returns 2, returns 1, return index 2. All right. So this is correct here. All right. So now I'm going to show you the second part, second way to do this. All right. So for the for this method, right, first we're going to sort and find right index. So we're going to create a variable called index and set that equal to array.sort, and then current, and then next, and then if current is greater than next, then find index of current number. Which is either less than or equal to current number. All right. And now we're going to return proper answer. So return index if index is equivalent to -1, return the length of the array, and if it's false, return the index. So to further explain, first I sort the array in ascending order. I sort the array in ascending order. This is currently done using array functions for minimal footprint. Once the array is sorted, we directly apply we assort the array in ascending order with this code here, and then once that's done, we apply the dot find index method, where we are going to compare every element in the array until we find where the number is less than or equal to the current number, meaning where the number we want to insert is less or equal to the current number in the iteration. Then we use the ternary operations here in this line to check whether we got an index returned or -1. We only get -1 when the index was not found, meaning when we get a false for all elements in the array, and for such case it would mean that number should be inserted at the end of the list. Hence why we use array.length. And so I click run, and we get the same output. And as we can see, this way is also another effective way, more of like a shorthand way of implementing this algorithm. Alright, and next I'm going to show you how to do the Caesar cipher algorithm. Alright, so one of the simplest and most widely known ciphers is a Caesar cipher, also known as a shift cipher. In a shift cipher, the meanings of the letters are shifted by some set amount. A common modern use is the ROT13 cipher, where the values of the letters are shifted by 13 places. Thus, A shifts to N, B shifts to O, and so on. Write a function that takes a ROT13 encoded string as input and returns a decoded string. All letters will be uppercase. Do not transform any non-alphabetic character, i.e. spaces and punctuation, but we will pass them on. So the basic way on how to do this, and we're going to use this encoded string as an example. And within our function rot13, we have a parameter string, and then right here we're going to split string into a character and into a character array. So we're going to type return keyword string dot split. All right, hold on, dot split, and we're going to iterate over each character in the array. Okay, hold on, use this comma, iterate over each character in the array. We're going to use the map method, and then we're going to use the call method, and then string comma function char. Okay, and then we're going to convert char to a character code. So x equals char dot char code at 0. Now, after this line, I'm gonna make another comment. Okay, next we're gonna check if character lies between A to Z. So if, I'm gonna shift all this. So if x is less than 65, or if x is greater than 90, to return string dot from character code x should, and this should return an unconverted character. Now, in is equivalent to ASCII key 78 if the character code is less than 78, shift forward 13 places. Alright. And so else if x is less than 78, return string dot from character code x plus 13. Otherwise, shift the character 13 places backward. In which use the return keyword again, string dot from character code x minus 13. Okay, and then here we're going to do dot join comma, and so we rejoin the array into a string. Okay, and I'm going to click run, and the decoded string says you did it. So to explain to you what I've done, a string variable is declared and initialized to store the decoded string. The for loop is used to loop through each character of the input string. If the character is not uppercase English alphabets, i.e. its ASCII doesn't lie between 65 and 91, we'll leave it as it is and continue with the next iteration. If it's the uppercase English alphabet, we'll subtract 13 from its ASCII code. If the ASCII code is less than 78, it'll get out of range when subtracted by 13, so we'll add 26 number of letters in the English alphabet to it so that after A, it'll go back to Z. And now I'm going to show you an intermediate level way to implement this algorithm. See you in the next lecture. Alright, now for the intermediate solution for the Caesar's cipher within the function, make sure you delete everything. And now we're going to create a variable called ROT character array. And then we're going to set it to empty brackets. It's going to be an empty array, and then var again, create a little bit of space here, var, and then I'm going to have reg x equal to / hold on, actually this is in between brackets, and then A to Z, and then / again, and then we're going to have string is equal to string dot split and I'm going to have a for loop var variable x in string, and then within the for loop we have an if statement regex dot test string open close brackets x, and then a more general approach possible because of modular arithmetic, and cyclic nature of right 13. Transform. Okay. And now we're going to have right car array dot push so string x dot car code at close parentheses minus 65 plus 13 modulus 26 plus 65. All right. Else ROT character array dot push character code at okay. And now, so this here is our if else statement, and then we have a for loop here. So after our for loop, we're gonna have string equal to string dot from character code dot apply string lt character array and then return keyword string. All right. And so, yeah, and this decodes string. All right, so to explain what we've done so far is an empty array is created in a variable called rot array. All right, this is to store the character codes. The regex variable stores a regular expression for all uppercase letters from A to Z. We split and hold on. Yeah, there's supposed to be a semicolon here. Yeah, but here in this line we split string into a character array and then use a for loop here to loop through each character in the array. Using an if statement within our for loop here, we test to see if the string only contains uppercase letters from A to Z. If it returns true, we use the character at function and ROT13 transformation to return the correct value. Otherwise, we return the initial value. We then return the string with the character codes from the rot, rot car array variable, from the ROT character array variable. Alright, and so if we click run, we get you did it again. So you see that this is another way in which you can implement the Caesar cipher. And next, I'm going to show you a third way on how you can implement the Caesar cipher, and it's a little more advanced but not as lengthy. Alright, so for the advanced method, the advanced way, um, we're just going to use the return keyword and then string dot replace and forward slash open close brackets capital A to capital Z forward slash G comma capital L fat arrow function sign string dot from character code L dot character code at 0 modulus 26 plus 65. Alright, and now I'm going to click run. Hold on, messed up somewhere. Oh, okay. Alright, so now I'm going to click run again, and you did it. So I misplaced a close parentheses, but yeah, you did it. Alright, so this only took one line of code. Yeah, regex, definitely using regex is definitely for sure a shortcut way to do these algorithms. As you notice, the more advanced, usually the more regex you see, regular expressions. So to further explain my code, string.prototype.replace here lets you transform a string based on some pattern match defined by a regular expression and the transformation which is applied to each of the pattern matches. Alright, and the arrow function here, this syntax is used to write the function parameter to replace parentheses. L represents a single unit from every pattern match with A to Z, capital A to Z here. This is every uppercase letter in the alphabet. The arrow function applies to the ROT13 transform on every uppercase letter from the English alphabet present in the given string. And this will be it for the Caesar cipher. And this will be it for basic JavaScript algorithms. And next, I'll be showing you how to do intermediate level JavaScript algorithms.